a little side note, because we haven't refreshed it in a while, I did put a couple things at the beginning relevant to trig functions that we need to recall. Anytime in calc we see trig functions, it's always in radians. If I were to ever give you something in degrees, you have to convert it into radians. And remember, in order to do that, yeah.
One or the other.
Right. We either multiply by pi over 180 or 180 over pi. So the thing to remember is that pi is equal to 180 degrees. So if it was ever given to you in degree format, we would have to convert it. But unless you are specifically told otherwise, we are assuming everything is radians in here. Also, as a common refresher, 30 degrees is equal to
Pi over 6.
45,
Pi over 4.
60,
Pi over 3.
90.
Pi over 2.
Pi.
And you could get any of those by multiplying by pi over 180, if you forgot. Another thing to remember about our trig functions, they're all continuous as long as the numbers involved in the domain. So sine and cosine, they were always continuous. Your other four trig functions, they did have asymptotes, so it's continuous between the asymptotes on those. And just as a side note, a couple formulas that we might use today. What's the most important trig formula?
Oh, sine squared plus cosine squared equals 1, yes!
And remember, back at the very beginning when we refreshed trig, I did give you a handout that had the formulas. Another one, I don't know if we're going to use it. It may not come up. Well, it might come up today. We'll see how far we get. This is not one that we memorized, but we might need to use it today. It's on that formula sheet I gave you at the beginning of the year. But if you have the sine of two things added together, sine of the first, cosine of the second,
Oh.
cosine of the first.
That was on the ACT. I did not remember that.
Wait, so this is
Who's on
like,
the AC?
this is like what?
I'm pretty sure it was.
Remember, we had all those sum and difference identities for our trig functions. We made our flip book of all of our formulas.
Can we make a flip book for derivatives?
Maybe we should. Maybe that should be part of the final.
Dude, no.
Be a part of our final? Can that be
Huh?
our final?
Yeah?
Wait, do we have a midterm? Or like a...
Yeah, we'll do a first semester and a second semester.
What is our midterm?
Oh, midterm. We have the semester final.
Okay,
Same thing.
another thing that we're going to use today that we saw back in section 2.2 was the limit as theta approaches 0 of sine theta over theta equals 1. We did learn that. Yep. We
Alright.
had that as a theorem back at the time.
That's so
You
sweet.
can look back at those notes. It's there. So,
Yes, ma'am.
all the things we've seen.
Oh.
We're actually going to start out not doing derivatives, but looking at a limit. So we have to have this because I want to prove to you what the
Wait.
derivative of a trig function is, so we need some limit things. Can I plug in 0?
No.
What do we do then?
Factor out.
Cosine theta plus 1.
Yes, let's try multiplying by the conjugate.
Oh, and then it's gonna be. Oh, I see the lines.
Okay. Then we have the limit as theta approaches 0. If we FOIL on the top, we get cosine squared theta minus 1. On the bottom, I'm not multiplying it out.
Sine squared.
Okay, so from our most important formulas that we just wrote down, we know sine squared plus cosine squared equals 1.
Looks like it's gonna be negative sine squared.
Would be negative sine squared.
Yeah. Let's go down.
Okay. Can I plug in 0 yet?
Nope.
Okay. But we have things being multiplied together, right? On the top I have a negative sine squared. So Can we agree that means you have negative sine times sine? Is that equivalent to sine squared?
Yeah.
Okay.
Oh no.
On the bottom, I have a theta times a cosine theta plus 1. Could I put cosine theta plus 1 with this one and theta with this one? If I multiply these fractions, are they what we started with? Okay. I cannot just straight plug in 0, but we know that if we have the limit of two things being multiplied, we can do their individual limits, right?
Sure.
Yeah.
Okay.
Oh,
So
sine
this is the limit
equals 1.
as theta goes to 0 of negative sine theta over cosine theta plus 1 times the limit as theta approaches 0 of sine theta over theta. Now the problem is right here because I can't put in a 0, but that theorem from section 2.2
It says it's 1.
says that's 1. Okay, this one, we can plug in 0. So sine of 0 is
Oh, it's 0. Yes. And then
okay. Cosine of 0 will be
2,
1.
1. Oh yeah.
So we get 0 times 1, which is 0.
No, it's not 1.
How's the because it's a square root.
Oh, right.
All right. Your book lists this as another result. If you remember this one, great. If not, we can always get it just by knowing that as theta approaches 0, sine theta over theta equals 1. But if you're following along in the book, they do now state this. So if this limit does ever appear and you just write 0 without working it out, I would assume you remembered the rule. Otherwise, you would work it out.
So we could just write 0 and everything. Hope that was right.
Well, you have a very small chance of getting that right. Okay. So we're going to use limits in a minute to actually calculate derivatives. But first, I want to try to guess what the graph or what the derivative of sine would be. What does the graph of sine look like?
Starts at
No,
0
high,
and
no.
goes up and down and up and down
Yeah,
to
but
1
there's-
and negative 1.
Yeah. Oh.
It's not a very good graph, but you get the idea, right?
Is it gonna be flippy flop?
Okay, so if I were doing the derivative, anywhere it had a high point, what would your derivative be?
Oh, 0. Never mind.
Anywhere it had a low point, the derivative would be?
0.
Okay, this section was increasing, which tells me the derivative was
Above the line.
above the axis. Okay, this section's decreasing, so it's
Is it cosine?
It is.
below the axis. This section's increasing, so
it's
it is
above.
above. Does
It's
that graph
cosine.
look familiar?
Oh my god.
Who
Okay.
thought of this?
So,
That's evil.
we think the derivative of sine might be cosine from the graph. Let's actually do the definition of derivatives and see. So, the definition was using the limits. So the limit as h approaches 0, f of x plus h. So I'm using, my function is just sine x. So f of x plus h is sine of x plus h minus f of x, sine of x, all over h. So that's our definition. Okay, sine of x plus h. Didn't I have you write down the formula for that today?
Sure did.
Okay, that turns into sine of the first sine x cosine h plus sine h. Okay. We're definitely not there yet, are we? Do we have any like terms? Nope, we can't actually combine anything. But what we could do, let's do this. I'm going to break this fraction up a little bit. Okay, I'm going to put this term and this term in the first parenthesis, or in the first bracket, because they do have a sin x in common. My other one is cosine x, sin h.
Wait. Oh.
You okay?
Yeah.
So I've just pulled apart my fraction a little bit. Reordered some terms. From here, we know we can do the limit of each one separately, right? The first one, I'm going to factor out that sin x. So it's sin x times cosine h minus 1. This one I'm going to kind of pull off the sin x for a minute.
Is H acting as our theta here? Is H acting as our theta?
X is like our theta. I mean, h is another angle, but we are approaching 0 for our h. Okay, have I lost anyone? So, can I, on the first fraction, would you guys agree sin x times this would be the same as saying sin x times this whole fraction? Okay, as h approaches 0, it's not going to change the sin x. From that first slide that we worked out, the limit as h approaches 0 of cosine h minus 1 over h would turn into 0. This one, cosine x, it doesn't have an h in it, so that won't change. What is the limit as h approaches 0 of sin h over h? So we get 0. What's cosine x? Just cosine x. So, we have proven that the derivative of sine is in fact cosine.
So how is sine of h over h1?
That was from section 2.2
okay.
rule.
Sure.
What?
I don't know. So sine of h over h is the same thing as sine of theta over theta?
As long as it's approaching 0.
Okay. So, okay.
Alright, so we've pulled in a lot of old trig stuff, really just so I could do this proof for you. And prove to you that, in fact, the derivative of sine is cosine, because I didn't think you believed me otherwise. And so now you believe
Yeah, I
me.
would've.
I know, Carson's
Crazy.
a doubter. So, we now know derivative of sine is cosine. So if I ask you to do this derivative, now, careful, we have two things being multiplied, don't we? So what do we have to do? Product rule. So one derivative at a time. So if I did the derivative of the first one, what's the derivative of x squared? 2x times the second plus the first one times, what's the derivative of sine x?
Okay.
So it's just 2x sine x plus x squared cosine x.
Oh, we don't go past it?
We can't go any further. No.
I feel like we
Yeah.
can.
Alright.
Actually, we're gonna do the second derivative and the fourth derivative.
So you remember that problem I
Alright.
said we can't
Is
go
this
further?
can't go further yet, or?
We can't go further.
Okay.
Ah.
Oh.
It's
Alright.
Tangent
I
is
like
like the.
Do you want me to prove what the derivative of cosine is?
It's okay.
You believe me after the derivative of cosine is actually
Sine.
negative sine.
Negative. Oh.
It turns out with our trig functions, all of the co's have a negative derivative. Cosine, cotangent, cosecant, all of their derivatives turn out to be
Just a-
negative. So, derivative of sine is cosine, derivative of cosine is negative sine.
What's the abbreviation for cosecant? CSE?
But then secant will have a positive cosecant.
What's the
So-
derivative of tangent is secant squared.
Derivative of tangent is secant squared. These are a little bit easier to prove. So if you ever forgot one of those, as long as you remember sine and cosine, you could get the others. We know tangent is the same thing as sine over cosine, right?
Ah, yeah.
So can we do quotient rule?
Yeah.
Low. D high, what's the derivative of the top?
Cosine.
Minus high. D low, derivative of cosine. Over low. Squared.
Could you write it as cosine squared?
So if we simplify it on the top, cosine x times cosine x is cosine squared x. Minus sine times negative sine, so minus negative would be positive. Sine squared x.
So that's just 1 over. Oh, I get it. That's hard.
Cosine squared plus sine squared is 1. And 1 over cosine squared is secant squared. So, sine and cosine are the hard derivatives to prove because they require so much other stuff. We have to go back to the limit definition. But if you know those, you can do the quotient rule to find the
So
others.
you really can't take calc without trig, huh?
It is a prerequisite for that reason. Alright. Let's do this one. So, if I wanted to do this derivative, I have things being divided. So I have to do what? Quotient rule.
Ooh,
So.
that's probably.
Low. D high. What is the derivative of sine?
Yeah, cosine.
Minus high. D low. Okay, what's the derivative of 1? 0, so we can drop that. Plus, what's the derivative of cosine?
Negative sin x. Oh my goodness.
Over low. Square.
That turned into sine. Right, okay.
So, on the top, we distribute. 1 times cosine x is cosine x. Cosine x times cosine x is cosine squared x. Sine and negative sine, so that would turn into a positive sine squared x. If it were 1 minus cosine squared, we could simplify the bottom, but 1 plus cosine squared, we can't.
Didn't that just make it negative sine squared?
It would have to be a
Can't
negative
you
1.
simplify it to cosine x plus 1?
On top.
Or something.
Okay, is everybody with me to this point?
Okay.
On the top, we have cosine squared x plus sine squared x. What is that equal to? Okay, so we have cosine x plus 1 over 1 plus cosine x squared.
1 squared.
Aren't these the
Are
same?
you missing a square? Oh, I'm dumb.
1 over.
But we can go 1 step further.
Did you figure out what?
Yeah, I had a square on the bottom for some reason.
Oh,
and that's why I was
okay.
confused.
So I can
I feel like
cancel
we can.
a 1 plus
No,
cosine
we can't. I was playing.
and get to this.
Hopefully not.
split it up, it'll be 1 plus secant.
No.
And then,
Alright.
and then we square it all, and 1 plus secant squared equals
Stop.
Questions here.
tangent squared equals
Okay. I'm stopping here, and I want you guys to try the first bit of problems.
oh my,
Are they book problems?
they are book problems though.
Oh,
So
wonderful.
6 problems.
It's only